everything the same, you change price of X. You reduce it. Find the new optimal point. Say there. Alright? Suppose you reduce it further. You find another one. Alright? You connect all these optimal bundles, we call it price consumption curve. So the price consumption curve becomes locus of all optimal points when you only change price of X. You don't change anything else. You don't change the income, you don't change the price of Y, just price of X. Fine? From the price consumption curve, you can get the demand curve. Because you're changing the price. That's a lower price, lower price, lower price. And finding optimal bundles. That is your demand curve. The demand curve is from price consumption curve. Alright? The price consumption curve being the locus of all optimal points when you only change price of X. So the demand becomes all optimal points. On the demand curve, you're maximizing your utility. Right? For different prices. Assuming everything else is constant. That's the demand curve. The demand curve is the locus of all optimal points where only price of X is changing. Nothing else is changing. Right? Given income, given price of Y, if you reduce price of X, those are optimal consumptions. Right? Okay. The way I graphed it though here, I graphed the price consumption curve as rising. Why? What does that mean? PCC is rising. What does that mean? Yeah?
X and Y are complements.
They're a complement because when the price of X declines, you buy more of both. It must be complement. So when I graphed it, X and Y, for this individual were complement of each other, right? You don't have to be. You can have price consumption curve that looks like this. I'm reducing the price the consumer consumes. The consumer consumes. On this line. This line. Because the downward sloping price consumption curve, you still get downward sloping demand. Still, when the price rises, falls, you buy more, but PCC in this case is downward sloping because this individual views X and Y as substitute. So the shape of PCC just indicates how these two goods are viewed, not about the demand itself. Right? In all cases, you get downward sloping demand. That is substitute. Or you can get it actually flat. You can get it like this. Straight line. Still, when the price declines, you buy more. That is when the individual views X and Y as, what's the name of the third one?
Independent.
So the shape of PCC does not have anything to do with the shape of demand, right? In all cases, you get downward sloping demand. The shape of PCC just tells you how X and Y are viewed, right, by the individual compared to each other. The relation between the two. Downward sloping, substitute, upward sloping, complement, flat, independent. Fine? Okay. That is the graph. So the graph is from PCC. The demand is from PCC. PCC is the locus of all optimal points. So what we did last session was just one point on it. Last session we did 1 point, on the PCC. The last session we assumed you know price of X, you know price of Y, you know the income, we optimized. That's technically 1 point is 1 point on PCC and 1 point on demand. If you want to find the whole demand, you need to generalize what we did. I solved for all prices, all income. Right? So if you want to find demand for this function that we used last session, was it 10? I think it was. Then don't plug the prices, even if the question give you the price. Say 2, 100. Don't put the numbers. If you put the numbers, you're just solving for those. Find for all prices, all incomes, then you can use the price and income at the end. Get the point you want. Alright, so ignore those. Generalize. Put MRS. That's your MRS. Equal to, write the price, but don't plug those numbers. Put notation. Right. That will give you Y equal to PX, PY, X. It's the same thing we did before, but I'm not going to put the numbers in it. I'm generalizing it. The budget line then looks like this. And then take this one there, and you will find demand for X. That's the optimal bundle for all prices, all income, which is demand. Right? Now, if you plug it there, that is what you get. That will cancel out. You have 1 here, 1 there. That's 2, right? And that will be demand for X. Right? I find demand for X. Then I can take this one and plug it there and find demand for Y. Last session, we just solved for these numbers and we got 25 and 50. Remember that? It was 25 and 50, right? We got 25 and 50, which was 1 point on the demand corresponding to income equal to 100. Price of X equal to 2. That goes 25. So last session we did 1 point on the demand. We call it optimal allocation of funds. If you analyze it, you'll get all the points. We call it demand. Make sense? Okay. If the income increases, what happens to demand for X? It will go up. So in the world of Cobb-Douglas, the good is viewed as normal. That's always the case. Cobb-Douglas corresponds to normal good. When the income goes up, you can see there. The demand goes up. Fine? What's the relation between price of Y and demand for X? If the price of Y goes up, what happens to demand for X? Nothing. Because X and Y are independent. PCC will be straight line. When you change price of Y, nothing happens to X. When you change price of X, nothing happens to Y. X and Y are independent. In fact, Cobb-Douglas is the only function that gives you independent goods. Right? Make sense? Okay. If you want to graph the demand, how does it look like? If you want to graph the demand, how does it look like? Suppose you want to graph the demand. By demand, I mean inverse demand, obviously. That is this. I want to graph that. How does it look like? Is it upward sloping, downward sloping, straight line, curve? How does it look like? Anyone? Yeah?
Is it curved downward sloping?
It looks like an indifference curve. If you think about it, if price of X goes to 0, how much is X? Goes to infinite. If price of X goes to infinite, that's a common theorem. So you get something very much like an indefinite curve. Downward sloping, but not a straight line. Make sense? Convex smooth origin will be our demand. Right? Okay. That's one. Example 2. This is the one we used last lecture. That was CS. Alright? So the process remained the same, the function just changes MRS, and the outcome will change with it. But the process is the same. What's the MRS of this function? Anyone recall the shortcut?
Y over x, 1 minus
So that should be yx, 0.5. That should be equal to relative price. So y should be ps squared, py squared, x. That is y solved for x. Just I squared both sides. That's right. That's equation number 1. Equation number 2 is our positive line. So the task is plug this there and solve it. Right? See, the process is the same. You just have a different MRS, so it gives you a different outcome. That will cancel out with this one. So what's the demand for x? It should be I. It should be I. Px plus px squared py. Am I right? Yes. Or you can write it this way if you want. Right? You can take the px out. And if you want to find demand for y, you can take this one and plug it there and solve it. I'll leave that to you, right? Demand for y found the same way. Take x, plug it in tendency, solve for y. Okay? Okay. If the income rises, what happens to demand? Will go up. That's a normal good too. In fact, we don't have a mathematical function that give us inferior good. They're all giving us normal good. There's no mathematical function we use that would ever give us inferior. They're all normal. Right? Okay. So inferior is just a graph. We never have a function for it. If the price of y goes up, what happens to demand for x? If the price of y goes up, what happens to demand for x? Well, this goes up. This goes down. This whole thing goes up. So what's the relation between x and y? They are substitute. Price of y goes up, demand for x goes up. That's substitute, right? So if you graph PCC, it should look downward sloping. It should look like this one. Downward sloping. Right? Make sense? Okay. Anyway. Okay, if you graph the demand, how does it look like? If you graph the demand, how does it look like? Like a straight line, curve, upward sloping, downward sloping, where does it hit the vertical line, horizontal line, stuff like that. If you graph it, how does it look like? Anyone? If price of x is infinite, how much is x? 0. It's the same. If price of x is 0, how much is x? It looks very much like Cobb-Douglas. Alright? It looks convex smooth torsion, very much like Cobb-Douglas. In fact, CS, Cobb-Douglas is just a CS with some characteristics. If you look at the CS as general function, one version of it is Cobb-Douglas. There's lots of similarities there. Not exactly the same. Lots of similarities. Make sense? Very similar. Cobb-Douglas is a version of CS. Alright.
I remember, I think you said that in Cobb-Douglas, the X and Y are not related.
I know, and they're not the same. You can think of Cobb-Douglas as a special case of CS. Right? It has more characteristics, it's more restrictive. Right? So Cobb-Douglas is a version of CS, it's a limit of CS. We can't, well, I'm not going to prove it, but that's it. There's a lot of similarities in the results. If you look at them, there's a lot of similarities. Both give you normal goods, both give you downward sloping demand that looks like indifference kind of stuff, but they're not the same. CS is more general, right? So in advanced macro is really used widely. In basic macro, you're gonna see a lot of Cobb-Douglas, right? Okay, anyway, but they're not the same, they're not the same. Okay, that is the first one, which is PCC and how it relates to demand. Suppose you change the income, not the price. Say, this is where you stand initially. That's where you optimize. Suppose your income goes up. What happens above the line? Shift out. Right? Suppose you consume there. Right? Suppose your income goes up further. So you consume there. You may say, why is there? Well, because 8 billion people, I found one who wants to do that, right? Specific preference. So this consumer, when the income went up, initially went from here to here, then it went to there. That line is called income consumption curve, which is locus of all optimal points when you only change the income. Everything else is the same. Make sense? So ICC is a locus of all optimal points when you only change the income. Nothing else is changed. Go down here, find the optimal point corresponding to X, and the income, put it on a vertical line. That's the initial income. That's how much you consume. That's the next level of income. That's how much you consume. That is last level of income. And that is how much you consume. If you connect those dots, that will be called angle curve. So angle curve will look like demand. But for demand, you change price of X and see what happened. For angle curve, you change the income, see what happens. Make sense? Right? Okay. In this case, the income is rising from I1 to I2. This individual goes from X1 to X2. Right? It consumes more. Then the income rises from I2 to I3. Then it consumes less. Why? Because the individual views X initially as normal. Then he views it as inferior. So angle curve tells you whether the good is normal or inferior. Upward rising is normal. Downward sloping is inferior. Right? The same with income consumption curve. I'll give you the same information. It will tell you whether the goods are normal or inferior. Upward rising means both are normal. Downward sloping means one is inferior. Right? Can you have an ICC where both become inferior? The way I graphed it, from here to here, both increase. Both are normal. From here to here, this decreases, that increases. That's inferior, that's normal. Can you have a case where you end up with both inferiors? Can you graph the ICC in a way that both goods are inferior? Yes or no? See, from here to here, normal. From here to here is inferior. That's for X. But for Y, you consume more than more. The way I graphed it, Y was normal in both cases. X was initially normal, then became inferior. Can you graph an ICC where both become inferior? Yes or no? Anyone? The answer is of course not. If you have money, if you have more of it, you have to spend it somewhere. You cannot spend it less on both. You can spend it less on one, but not on both. In the world of two goods, you either have both of them as normal or one as inferior. You can't have both as inferior because the money has to be spent somewhere. So in this case, upward rising was both normal, downward sloping was X is inferior, Y was normal. Fine? Make sense? Anyway. Okay, how you mathematically get the angle curve? We got the demand curve, demand function for our optimization. How do you get the angle curve? Well, you don't optimize twice. When you optimize for all prices and all incomes. So you already have the angle curve embedded in the optimization process. Can you see it? Somewhere there's an angle curve. You see it? Well, if I take this one and solve for price of X, what do I get? I get the demand curve. That's the demand curve. If I take that one, solve for the income, what do I get? That is our angle curve. So the angle curve is already found. We find the demand function. Just isolate for I. Right? That is our angle curve. Right? To graph the angle curve for Cobb-Douglas, how does it look like? Graph that one, how does it look like? Yeah? How does the angle curve looks like for that individual? It looks like straight line from the origin with this slope. The angle curve for Cobb-Douglas is a straight line from the origin with a slope dependent on the price. Right? Okay. What does a straight line angle curve mean in words? It's a straight line, right? What does it mean in words? It means if you double your money, you double your demand. Triple it, triple your demand. That means you proportionally spend the same money on X and Y. Say if you have $100, you spend $10 on X. If you have 1,000, you spend 100. That's the meaning of a straight line. Angle curve means the money spent on X and Y proportionally remains the same. Growth. Right? Make sense? Okay. That is Cobb-Douglas. What about here? Do you see the angle curve? Do you see the angle curve for the CS? That's the angle curve. That's your angle curve. Again, it would be straight line with constant slope. But the slope always depends on price of Y as well. It doesn't depend on price of X only, it depends on price of Y as well. But straight line. So you still get the same thing. You spend proportionally the same money on X and Y if you're characterized by CES. Make sense? As I said, they are very similar. Cobb-Douglas and CS are very similar.
Is it always a straight line?
It's always straight line. That's always true for Cobb-Douglas and CS. You always get a straight line. Angle curve meaning no matter what version you have, you spend proportionally the same money on X and Y. Right? Make sense? That is true for Cobb-Douglas, true for CS. No matter how much, how the function looks like. Okay, we're done with this one. This is left. I'm going to do it later though. I'm going to go to the questions, redo sum of 1 and 2 and extend it. Then we're going to do item number 3 and 4, which is the crux of demand theory. Question 1. Income consumption curve for two perfect complements is vertical line. True or false? Why is it false? explain it, but let's see if we can figure it out. The price consumption curve for a two perfect complement is straight line. True or false? That's true or false? That's true. So you're right. Let's see why. Suppose that is cream, that is coffee, and the individual uses 2 creams, 1 coffee always. Anything outside that combination, he threw it away. That's a perfect complement, right? If you give him 3 creams, 1 coffee, the 3rd cream is thrown away. It's useless. Because he uses one, right? If you give him 2 coffees, 2 creams, he's going to throw away 1 coffee. Fine? Okay. So it's characterized by perfect complement where he wants to stay on that line. What's the slope of that line? Based on a statement given. What's the slope of that perfect relation? That's 1. You want this to be 2. This should be. Right? So that is the line he wants to be on. Right? Make sense? That's coffee. That's cream. If you give him 1 coffee, he needs 2 cream. He gets some satisfaction from it. If you depart from it by having more cream, coffee, or more tea, more cream, it doesn't do anything. Make sense? If you give him 2 coffee, how many creams you need? 4. He gets some satisfaction. If he departs from it, he gets nothing. You will get what we call L-shaped indifference map. Right? And someone said that L-shaped indifference map can be characterized this way. For an obvious reason. Mean means if you depart from this line, either having more x or more y, you get nothing. Make sense? So someone said you can characterize that knife edge function using that. What was the name of that someone? I put the name last week. Yeah. Leontief. So this is actually called Leontief function. In the real world, everyone in the world of economics, everyone knows that name, right? It's called Leontief function. I've seen some people writing it with V. It goes both ways. Leontief or Leontief, both ways. In fact, initially it was invented for production, so they called it Leontief production function. Later on came to consumption. But that's the invention of Mr. Leontief. But you imagine that's not very easy function to characterize because it's not real mathematical function we know of, right? It's sort of knife edge. That's the way it characterized. Yeah.
Could you please draw the curve for the first part? Could you please draw the curve for the first part?
Which part?
Roman 1.
Number 1? I haven't done it yet. We'll go there. So this individual who is actually characterized by perfect complement will have to stay on this line. Make sense? If her income is this, where does he go? He goes there. What about if income goes to that level? He goes there. So where's the income consumption curve? The income consumption curve is that perfect combination line. That's what it is. If the income changes or price change, you're going to stay on that line. So that line will be ICC and PCC as well. Does that make sense? So the first question becomes, from a non-vertical line is an upward sloping line, which is characteristic of perfect complement relation. Right? Make sense? So you said it right, the first one, you said the second one. That's what you meant, right? You'll stay on perfect combination line when the income changes, when the price changes too. That is PCC and ICC as well. This is ICC and PCC. That's the line you stay on no matter what the price is, no matter what the income is. So that become PCC and ICC. Make sense? Okay. Anyway. Okay, that's the first one. Wrong. The second not correct for that reason. This one, we'll cover it in a bit. That is item number 3 and 4, which I haven't done yet. Now I can go to number 2. When the price of X goes up, Alex, PCC is horizontal. When it goes up further, it becomes upward sloping. What does that mean? I'll graph it, you tell me what it means. That is the initial bottom line. That's the bundle Alex consumes. Right? The price goes up. He will move on a straight PCC line. So that is B. That's what it said, right? When the price goes up, i.e. the bottom line shifts in, the PCC is initially straight line. I graphed it. Right? Make sense? Then when the price goes up further, so this is the initial price, that is when the price increases first, that is when the price increases second. The question says PCC remains upward sloping there. What does that mean? That's the individual. When the price increases first, he moves on a horizontal PCC, then he moves on an upward rising PCC. What does that mean? Everyone? What does that mean? That was on the test once. Using the graph, explain what this means. What does that mean?
From B to A, it means that they are unrelated. Right?
So for lower prices, he views X and Y as
Not related.
independent. When the price goes up further, he views X and Y as complement. Initially, when the price goes up, he just consumes less X, does not change Y, but they're independent. Then, when the price of X goes up further, he consumes less of both, they become complement. Right. So upward sloping is complement, downward sloping substitute, flat independent. Using that. Right? Flat independent, upward sloping complement. Right? So initially, for lower prices, X and Y are independent, then they become complement. Okay? Okay. Okay, let's do more. Iris derives her satisfaction from only two goods. No relation between this iris and our iris. Like completely random thing, right? Iris derives her satisfaction from only two goods. That is her characterization. That's called Douglas. Alright? That's called Douglas. We can solve it exactly the way we did it. We need angle curve, we find a demand function. In it, there's everything. In it, you get demand curve, you get angle curve. We need the MRS. What is the MRS? What's the MRS? 0.5, 0.75, yx. That should be 2y, 3x. That should be equal to relative price. Make sense? Okay? Okay. Then I solve for y. That is my equation 1. And equation 2 is my what is mine? Alright? So now I have to take this one, insert it there, and solve it. Alright? So let's see what we get. that will cancel out. That is only true for Cobb-Douglas. For Cobb-Douglas, parts of y will cancel out because it's good or independent. That's only true for Cobb-Douglas, right? For anything else, it doesn't really cancel out. So how many we have here? We have 1 here. And how many have? That's 3 over 2, right? That should be 5 over 2 dxx. Alright? Yes, 5 over 2. So demand for x becomes 2I phi px. Right? I found demand for x. I can find demand for y by taking this one, plugging it there. That's the way you should do it, probably. But Cobb-Douglas has shortcut for everything. That's the reason it's so widely used. There's shortcut for everything in Cobb-Douglas. Cobb-Douglas always give you I price. The multiples always add up to 1. That's always the case. So if you have 1, you can infer the other one. By that, rule of thumb, this is IPY. What's the multiple? The multiple should be 3, 5, because they have to add up to 1. So if you found 1, you can shortcut the other one. For Cobb-Douglas, there is shortcut for everything, right? So the multiple should add up to 1. If I find this one, I know this is 3 over 5. If this was 1 over 4, this should be 3 over 4. Make sense? Again, that's just for Cobb-Douglas. For anything else, you basically have to take this one, plug it in, and solve. Yeah?
Could you just repeat it?
See, for Cobb-Douglas, you get demand I, the price of that good, and a multiple. The multiple will add up to 1. So if you have 1, you can infer the other one.
Okay.
So here I have the first one, 2 over 5. I know this should be 3 over 5. Because you have to add up to 1. Right? Make sense? Again, that's just for Cobb-Douglas. For anything else, substitute. Okay? Make sense? Okay. Anyway. Now the angle curve for x will be solved easily. That's the angle curve for x. So that's the angle curve for x. And for y, it would be this one. That's the angle curve for y. So when you find the demand in it, there's other things. You can find demand curve, you can find angle curve, they're all already there. Yeah. Why did I inverse? I inverse which ones?
Like y is like 5 over 2 and not 2 over 5. Whatever, man.
Let's multiply that. Okay, yeah.
This is the question. How do you get 5 over 2 dx? Like,
Oh. I hate this thing. I don't know who designed this thing. This is terrible. There's 2 things I hate about it. First, they put a plug down there. So every time you come, you should bend in. Why did they put one up there? Who designed these things, right? They could have put a plug up there, right? They obviously someone uses it. Why have to bend in, right? Anyway, not very smart people. Okay, this has been there for like 50 years. They should change it. I solve for I. I just cross multiply. It became 5x, 5x, I divided by 2. I just solve for I.
I'm sure on the left side of the screen, you know how you have
This one.
a little above that? This one,
This
yeah.
one?
How'd you get 5 from 3?
That's 1, that's 3 over 2. That's 5 over 2.
Got it.
Pxx, 3 over 2 pxx.
Got it.
Add them up. Alright, that became 5 over 2. Make sense? Okay, anyway. If you don't like it, just write 1.5, write 2.5. It's the same thing. But then when you flip it, it's ugly, right? So I wrote it as a ratio. Make sense? Yeah.
Are those 5 or 3? I interpret code 5 over 2 creation x. Is that 5 or 3?
That's 5 over 2. This is what you get. Pxx plus 3 to pxx. So that's 1. That's 3 over 2. That's 5 over 2. Right?
The 2 is the
Yeah?
bottom part.
This one?
Yeah.
Yeah, I took this one, I solved it for I. So this becomes I. That is 5 over 3 py. Y. That's x. Right? Make sense? Okay. Okay. I sure did a lot of stuff, right? That's the way it goes. If you like it differently, just solve it differently, right? But everyone is used to do it one way. Some people are comfortable writing it, some people aren't. Solve it the way you want, right? Make sense? Anyway, okay, next one. That is called perfect complement. How do you find the demand for perfect complement equation? You may say this got to be very hard. How do you find MRS? There is no MRS. This type of indifference curve does not have an MRS. You may say MRS here is 0, here is infinite, but you're never there. You're always there. At the dot, there is no slope. There is no trade-off. MRS is a trade-off. There is no trade-off, right? So there is no MRS. So there is no MRS. How do you solve it then? Well, you don't need MRS. MRS was needed because a typical individual decides based on the relative price. You put MRS equal to relative price, see how he decides. Y is a function of x. That was the process. For perfect complement, he decides regardless. The perfect complement will decide a relation between x and y based on perfect complement relation. That becomes your equation number 1 then. That's the equivalent to your tangency condition for other functions. Make sense? So if you want to find a demand for perfect complement, use perfect complement relation. Solve it for y. That is your equation number 1. Equation number 2, as always, is your budget line. So it's very easy to work with perfect complement. For some people it looks hard because the function is not fun. Well, the function is weird, right? Otherwise, just the function means you always consume on that line. So that becomes your equation number 1. No matter what the prices are, you consume on that line. Unlike Cobb-Douglas, where what you consume depends on the prices. Make sense? Anyway, your task now is take this one and plug it there. And then solve it. That will give you demand for x. So what's the demand for x? I px plus py divided by 4. Make sense? Yes. I took the x out, divide. Or if you don't like it this way, you can write it this way. 4I, there's enough space there. You can write it this way if you want. 4I, 4px plus py. Multiply the numerator and denominator by 4 and write it that way. Both are the same. What's the demand for y? Well, use this one. Take this one or this one, either way. Divide by 4. Right? You can end up with demand for x, for y, which is this one. I found demand for x. I found demand for y. Right? Make sense? Okay. Question 1. If you graph the demand for x, how does it look like? If you graph demand for x, how does it look like? Is it a curve? Is it a line? Is it downward sloping? Is it convex? Is it concave? How does it look like? Use your math imagination. Graph this one. If price of x goes to infinite, how much will be x? 0. So that is this side. Converges to 0, right? That looks like Cobb-Douglas. What about if price of x is 0? Do you go to infinite? Yes? If this is 0, or no? You have it both ways. If this is 0, that's not infinite. So it looks like Cobb-Douglas, but it hits the horizontal line. Because if the price of X is 0, you're going to end up with this one. Make sense? So sort of downward-sloping, convex, looks like Cobb-Douglas, what we had earlier, but it hits the horizontal line. It doesn't go to infinite, right? Slightly different. Make sense? Right? The way I graph it, if this is infinite, that's 0. That's one end. But if this goes, the price goes to 0, you hit that horizontal line. At this level, which I wrote there. Right? Okay. Anyway, how would what's the impact of price of Y and demand for X? If price of Y goes up, what happens to demand for X? It goes down, the complement. In fact, this is the only function that gives us complement goods. We have no other function that gives us complement goods. So that's that. What about the Engel curve? How would the Engel curve for X looks like? That is your Engel curve. That's Engel curve. Take this one. Solve for I, which I did. Solve for I. That's the Engel curve, right? If you graph the Engel curve, how does that look like? If you graph the Engel curve, how does that look like? Anyone? How would the Engel curve look like? Is it a curve? Straight line? A straight line. It's basically what we had earlier, straight line. The slope is this one. Look, very much what we got for Cobb-Douglas CS. All of them give us straight line Engel curve, meaning you'll proportionally spend the same money on X and Y. Right? If your money doubles, you double consumption. Yeah. But
How did you get the function for income? Just real quick.
I just take the demand, solve for I.
Yeah,
That's
solve for X, solve for I.
I just solve for I. I took
Oh.
this multiplied by this. Solve for I. You take the demand, solve for I. That's the Engel curve. You take the demand, solve price of X. That's the demand curve. By demand curve, I mean inverse demand function. You don't need to optimize again. When you optimize for all price of all income. So embedded in this one is everything. Make sense? Okay? Okay. Solve for I. Take this, multiply by this, and that's what I do. Okay? Okay. Anyway, we finished the first topic. We are at the next one, which is item number 3 and 4. That is the crux of demand theory, which is why people do what they do. Why, when the price changes, people consume what they consume. So this becomes the crux of demand theory. Let me take you to question part 1. This is the one we solved. We found a demand for it. So we're operating on this demand now. So let me put numbers on it. Suppose price of X is 2, price of Y is 1, the income is always 100. What's the demand for X? What's the demand for Y? We call that initial bundle. How much the initial bundle will be? Lock the numbers in the demand, bundle. How much will demand for X? How much? You're so shy. Some of you look like you're beat down like crazy. Someone like shot you multiple times. No. It's too hot here, right? The room is too hot, too cramped. And this stuff is not very easy. The good thing is we're at the end of the hard stuff almost, right? There's a couple of topics left, but it slows down a bit. Make sense? There's a lot of time to digest them. Put the numbers there. What do you got? That is 25. So this is 25. This is 50. That is the initial bundle. When the price is 2 and 1. Suppose price of X drops to 1. Price of Y is still the same, income is still the same. What would be your optimal bundle? What's the optimal bundle? When the price drops from 2 to 1. You're going to consume 50 and how much Y? 50. Y and X are independent, so I'm not going to change that. Y, you're going to change X, consume 25 more. We call A to B total effect of the price change, which is obviously observable. You can see A, you can see B, you can see you move from A to B. That is the total effect of the price change. You consumed 25 more units. That is observable. You can see it. Make sense? Okay. The question is, why that happens? Why you consume 25 more? Right? Does become the cross of demand. Why you actually consume 25 more? Conceptually, you reacted to two things. First, this is cheaper. You reacted to that. We call that substitution effect. Right? Second, when the price went down, you ended up with more money. Your purchasing power went up. You react to that as well. That is called income effect. We know that 25 is these two added up. We want to decompose it. Make sense? I said this in lecture number 1, I guess, but unless you actually go and solve it, you don't know what is going on. So we're going to numerically solve it here. Let's see. I want to actually find those two numbers. Let's see how we do it. Let me graph the original budget line. That's the original budget line. Right? Let me graph the terminal budget line. The consumer consumed at point A, that's 25. Then he consumed at point B. That is observable, we called it total effect of the price change. We know that is two parts added up. Conceptual at least, we want to find those two. Right? Okay. Technically, there are two ways to do it. If you somehow found substitution effect, the income effect can be found from total effect. If you somehow found income effect, substitution effect can be found from total effect. So you can isolate for one, find the other one from the total. Alright? The easier way to do it is to find substitution effect. Because it's easy to eliminate the income effect. Not easy to eliminate substitution effect. But not very hard to eliminate the income effect. Let me show you how. This is your original indifference curve. See, that is where you stand initially, then you went there. You look at the new budget line, what do you see? That's the new budget line, what do you see in it? Difference low, and different location. Why this is all the way to the right of this one? They give you more purchasing power. Make sense? So the new budget line give you different slope, more purchasing power. Right? I want to get to the more purchasing power. How do I do it? I should take this one, push it backward. Right? If I push this backward, I'm eliminating the income effect. Right? I'm getting rid of more purchasing power that he has when the price went down. Right? How far do I go? I should go all the way to the tendency. Because anything less, you still have more money than before. Anything more, well, I took away too much money from it. I should push it back all the way to tangency. At that point, he is as happy as before. That means I took away all extra purchasing power that came through lower prices. That will isolate for substitution effect now. So I should eliminate the income effect, and income effect eliminated at tangency. See, that is the income effect eliminated. So I took money from him. If I take anything more, he's unhappy now. I got too much money from him. If I go anywhere to the right, I left too much money with him. He's happier than before. I should take money enough to make him as happy as before. That's the tendency. Right? So at point C, no income effect is left. Now I can say this is substitution effect. That is XC minus XB, sorry, XA. And this becomes income effect, which is XB minus XC. By eliminating income effect, I was left with substitution effect, and then I can say the rest must be income effect. So the only thing I really need to find is C. How C is numerically found, that's the next step, I'm going to do it in a bit. But if I found point C, graphically, that is point C, that will isolate for substitution effect, then I can find the income effect from leftover. For this individual, for that Cobb-Douglas, the income effect was positive. Why? When money went up, he consumed more. Why? Because the consumer viewed X as normal. The reason the income went up, he consumed more because he viewed the good as normal. Right? That's for Cobb-Douglas. But if B, for someone, not this guy, ends up between A and C, what does that mean? Suppose for someone else, B ended up between A and C. B was, say, here. What does that mean? That means the substitution effect tells you to buy more, but the income effect is opposite, tells you to buy less. That is what we call inferior good. Inferior good is where the income effect is negative. The price goes down, the substitution effect says buy more, but the income effect says buy less. For this individual, the buy more signal was stronger than buy less signal. He still bought more. He still bought more. Is it possible for the income effect to be stronger than substitution effect? It's very rare, but it's possible. If that ever happened, we call the good different. That happens when B is to the left of A. The substitution effect says this is cheaper, buy more. You go from A to C. But the income effect says you have more money, buy less. And buy less is stronger than buy more. That's a given good. That will give you what we call upward sloping demand. That's a given. 100 years ago, observed in US, when price of potato was going up, people were buying more. When it's going down, they're buying less. How is it possible? How is it possible? This is the outcome. Potato was given good. It's not liked by people. But people were so poor. When the price of potato was going up, the only thing they can buy to satisfy their 2,000 calories was potato. They bought more of it. When the price went down, it allowed them to buy better stuff. They bought other stuff. Make sense? So upward sloping demand basically means you really don't like X. But you're so poor you can't actually afford anything else. When the price goes up, so you buy more of it. That's very rare, right? Very, very rare for you to see different good. Because you must be so poor spending most of your money on one good. And obviously it doesn't happen in the cities. It may happen in some rural areas, or it may happen 100 years ago when people were actually getting it. Make sense? Anyway, given good has two characteristics. Must be inferior. Number one, so inferior that the income effect is stronger than substitution effect. Right? There are lots of inferior goods. But satisfying this one is very, very hard. So there will be very, very few given good if ever. Right? That should allow us to answer this one now. That should allow us to answer this one. By the way, all the function we use mathematically will give us normal good. We don't even have an inferior good. Numerically, let alone given. It's just a graph. Right? All the function we use, Cobb-Douglas, Sears, F and complement, anything you use, give us normal goods. So you never find negative income effect. When the price goes up, the income effect says buy less because you have less money. That's always the case for us. You can't go all the way around numerically. So don't worry about it numerically, but you should be able to graph it. Right? Okay. You should be able to answer part 3 of this question now. True or false? Part 3. Is that true or false? False? The question says if income consumption curve is downward sloping, the good is given. True or false? That's false. That says IE is less than 0. That says more money, less consumption. Less money, more, that's inferior. Not given necessarily. To make it given, you need second condition. And that's very hard to satisfy. Alright? There's a lot of inferior goods out there, but very, very few given. Alright? So that is false. What about number 4? That is true. Right? Okay. Let's see how it works. This is the wall of goods. This is all of goods in the wall. Very small part are actually inferior. Very small part. Very small part of the inferior are given. Alright. Yeah, some inferior goods. Inferior goods are not really a lot, kind of minorities, but there is considerable number of inferior goods. Given is actually a tiny, tiny part of it. So this condition is very hard to satisfy. The income effect most often is not stronger than substitution. Alright? Make sense? Okay. Okay. Let me graph it for you and tell me what you see there. That's the price. That's A. Right? That's A. That's the price. Somewhere on it is B. Somewhere on it is B. Right? That is your initial indifference curve. Right? Make sense? So I gave you the initial point. I give you terminal point. I gave you the bottom line. Right? That is where the income effect is eliminated. Just call this one C. Make sense? So what is the terminal point? If the good is inferior but not given. The good is inferior but not given. What is the terminal point? I gave it the initial point, and I gave it the point that eliminates income effect. So this is what we call substitution effect. The good is inferior but not given. Where is point B? Yeah. In between A and C. That is somewhere there is B. So the income effect says opposite, buy less but not very strong. So you still buy more. That is inferred but not given. Alright? If it was given, where will be point B? It would be to the left of A. Stronger than substitution. Right? Goes to the left. Make sense? Okay. What if the good was just normal? Where will we be? If the good is just normal. It will be to the right because both are the same direction. Both tell you to buy more. Make sense? As I said, the function we use, they're all normal goods. The direction of substitution income are the same. As Carl Douglas says, everything we use is just a graph. Right? Okay. The same thing is what you see here. The initial point is A. That's what the question says. That's the initial point. Right? That's the no initial bottom line. The bottom line shifts. C is our terminal point. C. So what is A to C? What is that distance? A is the initial point. The price goes down, you go to C. What is A to C? Is it income, substitution, total? Which one is it? That income? Which one? That's the total. That's the initial bottom line. That's A. That's the terminal one. That's basically B on the prior notation, right? C is basically our B. A to C is the total effect of price change. Alright? That's the total effect. Make sense? I took the no bottom line, I brought it back. That is an attempt to eliminate what effect? I'm eliminating what effect?
Income.
Income. So point B isolate for what effect? Point B isolate for what effect? What is A to B? A substitution effect because I got rid of the income effect. I shifted the budget line backward, eliminating the extra purchasing power, right? So B to C should be what effect? That is income effect. The income effect is negative and stronger than substitution effect. The good is called given. That's a given good. The income effect pushes it back all the way past the initial point. That is what we call given. That's a given good. Right? Upward sloping demand. That's true. That's true. That's true. Right? I normally use A, B, C, but here we use A, C, D. Right? Okay. What about the fourth one? Y is an inferior good. True or false? Is it false or true? We already established X is inferior. You cannot have Y inferior too. That's without looking at the graph, right? If X is inferior, you cannot have Y inferior. Or you can say, when the income goes up, I buy far more Y. That's normal. That is false. Alright? But you can see it in the graph. When the income rises, although you buy that X, you buy far more Y, right? Make sense? Y is right? Make sense? Okay. We'll take a break. I'm gonna do two questions. One price going up, one price going down. You're gonna do one on your own on the quiz. We may do more next week. That's like 4 or 5 of them. That will help. If it doesn't, then God help you. You start. You won't be able to do it. But 4 or 5 should be good enough. It's all the same, but it's a multi-step process. You need to practice. All right? We'll take a break though.